Okay, we are going to go through some of the examples on the word problem packet that you got in class. Um, if you were gone, you can go to our PowerSchool page, um, to the Chapter 5 page. Let's see if I can pull it up here. Chapter 5, second semester, go to this linear word problem packet. That right there, click on that, and that's the packet I'm referring to. So in class, we started this example. I'm going to finish it, and then your homework yesterday was to finish number 2 and number 3. So we're going to go over those first. Okay, so one thing I mentioned was that when you get a word problem and you get an equation, it's really helpful if you can identify what each of these variables represents. And the problem will usually tell you. So the total cost is y, and x is hours. Okay, and we're renting a bike for $5 an hour. That's what the problem's all about. So we're supposed to graph this function. One way you can graph, if you're unsure, is to make an XY table. So let's plug in some values for x. So if you plug in a 0 for x, 5 times 0 is 0. If you put a 1 in for x, 5 times 1 is 5. If you put a 2 in for x, 2 times 5 is 10. If you put a 3 in for x, 3 times 5 is 15. Okay, now what we're going to do is we're going to graph the function. So x goes on the x-axis. That's hours, the amount of hours we're renting the bike. So we can rent the bike 0, 1, 2, 3, 4, 5, 6, 7. And the y is the total cost. So that's going to go on our y-axis. And if we look at our numbers here, it looks like they're going by fives, right? So maybe what we would want to do is have our y-axis go by fives. So this would be 0, 5, 10, 15, 20, 25, 30, 35. Okay, so now if we start plotting this line, the point 0, 0 would be right here. Then we'd have the point 1, 5, so we'd go over 1, up to 5. Then the point 2, 10, go over 2, up to 10, 3, 15. And then you could see that the pattern is going to continue. And you can fill in the rest of those dots and put a line through them. All right, so that's part A. Part B, what's the slope of the line? Well, here's our equation again, y equals 5x. Now that kind of looks like y equals mx plus b. The only problem is there's no plus b. So essentially it's like plus 0. So if that helps you to see that this is an equation of a line just like this, then when it asks you for the slope, it's just the number in front of x. So in this case, the slope is 5. What's the y-intercept of the line? Well, b is the y-intercept. So in this case, the y-intercept is 0. And you see how it hits the y-axis? Here's the y-axis. It hits at 0. And then the next question is, how much will it cost to rent the bike for 4 hours? So here's our equation. Remember, x is the number of hours. So if we're renting for 4 hours, we're going to put a 4 in for x. So it'll cost us $20. Okay, so now you had to finish number 2 and number 3. So let's scroll down there. And I'm going to have to erase all of those. Okay. So for number 2, this time we have the equation y equals 8x. They tell us x is the number of yards, and we're buying fleece fabric to make blankets or something. Y is our total cost. Okay, and we're going to graph, so we could make an XY table. When you put a 0 in for x, 8 times 0 is 0. When you put a 1 in, 8 times 1 is 8. When you put a 2 in, 8 times 2 is 16. When you put a 3 in, 8 times 3 is 24, etc. So x is the yards. So on the x-axis, we're going to label that with yards and go 0, 1, 2, 3, 4, and so on. The y-axis was the cost, and our y values, to see how they're going up by 8 each time. So, I mean, I could label it 1, 2, 3, 4, 5, 6, 7, 8, but then I'm going to run off my table very quickly, my picture very quickly. So maybe if I go by 8s, that'll make it nicer. So 8, 16, 24, 32, 40, 48, 56. All right, now if we plot these points, here's 0, 0, then we have 1, 8, 2, 16, 3, 24, and it would just keep going. And then draw your line. Okay, so we graph the function. What's the slope of the line? Again, here's our equation. There's nothing being added on, so if you like doing that, that'll help. The slope is 8, and the y-intercept is 0. And then part D says we need 6 yards to make blankets. How much is that going to cost? So in our equation, remember x was the number of yards. So if we're buying 6 yards, put a 6 in for x. And 8 times 6 is 48. We could also get this by looking at our picture. So if we went to 6 yards, we would go up to here, which is $48. And then part E, how much does it cost per yard? Okay, so how much are you increasing your cost by every time you buy a yard of fabric? So it looks like every time our yard goes up by 1, our cost is going up by 8. So it's costing us $8 per yard. Okay, so that was number 2. Now we're going to go on to number 3. Okay, got those erased. After visiting relatives who live 200 miles away, your family drives home at an average speed of 50 miles per hour. Your distance, y, okay, so y is your distance from home, is given by this equation. X is the time spent driving. Okay, so right away I know that I can put time on the x-axis and distance on the y. Okay, and we're told to graph the function. And here's our equation again. And you're a little bit more used to seeing your equations when they look like y equals mx plus b. So if you like this better, just rearrange the equation. So we could put the negative 50x first, and then this is a positive 200 that we could put second. Okay, so now if you remember the fast way of graphing lines, we wouldn't have to make an XY table, although you could. But this is our y-intercept, 200. So it's going to start at 200 on this y-axis. And then our slope is 50, negative 50. So if it's negative 50, that means we're going to go down 50 and over 1. So that might help to kind of figure that out first so that we can figure out how we want to label our graph. So time is in hours. So maybe we could just go by ones. So 1 hour, 2 hours, 3, 4, 5, 6, 7 hours. And then distance is in miles. And if I know my y-intercept is 200, I have to put 200 on here. So I'm not going to go by ones or twos. So maybe what we should go is like by 50s. Maybe that would fit nicely. So 50, 100, 150, 200, 250, 300. Okay. Oh, and the other thing to remember is that the y-axis represents your distance from home. And it looks like, since our slope is negative, our line's going to be going down, so our distance is going to be decreasing. So it looks like we're driving back home, not driving away from home. Okay, so our y-intercept is 200. Put a dot on the y-axis at 200. And then our slope says we're going to go down 50 to the right 1. So if I go down 50, that would be here to the right 1, down 50 to the right 1, down 50 to the right 1, down 50 to the right 1. So that's our line. And then the next question asks, what's your distance from home after driving 2.5 hours? Okay, 2.5 hours would be here. Where does that hit our line? Right about there. You'd have to kind of eyeball it. Okay, so it looks like it's near 100, but I would prefer to get an exact answer. So I think we should use our equation. We're driving 2.5 hours. Remember, x is the time. So I would plug 2.5 in for x. So 200 minus 50 times 2.5. And you can type that in your calculator and you're going to get 75. And again, y represents miles. So we are 75 miles from home when we've been driving 2.5 hours. And that matches our picture pretty well. So here's 2.5 again. This is about 75. That looks right. Okay. So that is going over what your homework was. And now what we're going to do is another problem together. I will put that in a second video just to keep the times on these videos a little bit shorter. So go to the next video.